Students, now in our next type of questions, we have e raised to ax sin bx and e raised to x cos bx plus c, but this time the terms of sin and cos will be with some powers. Observe very carefully the questions written on the board. You have y is equal to e raised to ax cos square x into sin x. The next term is sin square x into cos x. Cos square x into cos x, cos square x into sin x, isn't it? So here you'll be having a power to the trigonometric term. Otherwise, the problem is very much similar to what we have solved in the previous time. So students, here, let's take two questions, say first and second, isn't it? You have e raised to ax cos square x into sin x, e raised to ax sin square x into cos x. So let's very quickly begin with the very first question. So you can observe here y is equal to e raised to ax cos square x into sin x can be written as, we have e raised to ax cos square x into sin x. So obviously I need to first of all bring down the power, isn't it? The power 2 will be brought down to power 1. So I can write this is y is equal to e raised to ax cos x into cos x into sin x, isn't it? Cos x into sin x. Now you can observe that this cos x into sin x can be associated together and I can multiply and divide by 2. So that will transform it into a half angle formula. So I can write here y is equal to 1 upon 2. You have e raised to ax. You have cos x, and now you are writing 2 into. Let's change the order also. Cos x into sin x can definitely be written as sin x into cos x. Now, you know that this 2 sin x cos x is half angle formula sin 2x. So, I get 1 by 2 e raised to x into cos x into 2 sin cos is what? Sin 2x. So, I write cos x into sin 2x. Now, we all know that you should always write the largest angle at the beginning and then you should continue with the smaller angle. So, sin 2x will be coming at the beginning and then I'll be writing cos x. So, this becomes equal to 1 upon 2 e raised to ax into, I write sin 2x and then I write cos x. Now, you are very familiar with the de-factorisation formulas now. This is sin 2x into cos x. What I need more is 2. So, again, I'm going to bring this 2 and then you can write 1 upon 2 outside also, isn't it? So, this has transformed into 2 sin 2x into cos x. You know the formula 2 sin a into cos b. So outside I can have 1 by 2 into 1 by 2, that's 1 by 4. Then e raised to x into, what is the formula for 2 sin 2x into cos x? The formula is very simple. It is sin a plus b plus sin a minus b. So this becomes, put a bracket, students, make use of a bracket, isn't it? De-factorisation formula is going to give us 2 terms. So let's make use of a bracket. So 2 sin a cos b, sin a plus b, so 2x plus x. That's 3x and then plus sine of a minus b. So that's 2x minus x. You get x. The outside e raised to ax can now be multiplied inside the bracket. So can you observe that the first and the fourth question are exact copies of each other, isn't it? The first and the fourth question is definitely going to be a copy of each other, because in the fourth question you have e raised to ax. A is taken as 1 over there, isn't it? So 4 is exactly similar to the first question. So I can now have this e raised to ax multiplied inside the bracket, isn't it? So I get 1 upon 4, maintain the bracket, students, isn't it? You are going to multiply e raised to ax inside the bracket. You are still going to end up with 2 terms. So maintain the bracket. So my first term is going to be e raised to ax into sin 3x plus e raised to ax into sin x. So this looks like e raised to ax into sin bx plus c, e raised to ax into again sin bx plus c. You know the formula, isn't it? So I'm going to differentiate n times. So differentiate n times. I get yn is equal to 1 upon 4, then a bracket. So you know what the formula comes for e raised to ax into sin bx plus c. It is r raised to n, isn't it? So here there are 2 different terms. So for the first term I'm going to make use of r1 and then there is phi 1 going to come, r raised to n into e raised to ax into sin bx plus c plus n phi. So phi is going to be different for both the terms, isn't it? Here you can observe that A is itself A and B is 3, whereas here B is going to be 1. So obviously R and the value of 5 is going to be different for both the terms. So I'm going to make use of R1 over here. So R1 e raised to ax into sine bx plus c. So that's 3x. There is no c is 0 plus n phi 1. That's the formula for the first term. And then plus, students, I write R2 e raised to ax, isn't it? And then sine of x plus n phi 2. Now I clearly want to tell what is R1, R2, phi 1 and phi 2. So let's quickly write it over here. So students, what is R1 going to be? It is root of a square plus b square. A is a, b is 3. So I get a square plus 3 square. So it simply turns out to be a square plus 9. Nothing happens to a square plus 9. It will remain a square plus 9 itself. So a square plus 9, and phi 1 is going to be tan inverse of b upon a. So b is 3, a is a. So I get b, which is 3 upon a. So that's R1 and phi 1. And likewise, students, what about R2? It is going to be under root of a square plus b is 1, isn't it? For the second term, e raised to ax sine bx plus c. C is obviously 0. B is 1. So a square plus 1 square, that's going to be 1. And phi 2 is going to be tan inverse of b upon a. So I write 1 upon a. So you need to always clearly specify the values of R1 and phi 1. So now when we move to the second question, what will happen? In place of sine square x, you have sin x and cos x, isn't it? So in place of this cos and sin, you get sine and cos. So again sine into cos has come, isn't it? So I'm going to solve the first few steps. Later on, you need to practice the remaining solution on your own. So for the second question, students, what will happen? For the second question, I can say y is equal to e raised to x. I write sin x and cos x. So what is this sin x into cos x? It is going to become sin 2x. I need multiplication with 2. So 1 by 2 is going to come. So therefore I get y is equal to 1 by 2 e raised to x. 2 sin x cos x. So 2 sin x cos x has now transformed into, so there is first sin x and then 2 sin x cos x has become sin 2x. Always write the higher angle first. So e raised to x, you write sin 2x at the beginning and then you write sin x. Now you can see that this is a de-factorisation formula. 2 sin a sin b, you simply need to multiply by 2. So you multiply and divide by 2. So this 2 sin a sin b will give us cos a minus b minus cos a plus b. So outside I'm going to get 1 upon 4. Then I have e raised to x, put up a bracket, very important. You need to make use of brackets at proper places, students. So 2 sin a sin b is cos a minus b. So cos a minus b. So 2x minus x, that's cos x. And then minus of cos a plus b. So cos of 3x. So this time when you take e raised to x inside the bracket, the terms that you are going to get is, first term is e raised to x cos x. Second term is e raised to x cos 3x. You very well know what has to be done further, isn't it? Now you can make use of the nth order derivative. The formulas that you are going to make use is e raised to ax into cos bx plus c, isn't it, for both the terms? Obviously for both the terms the value of a is same, which is 1, but the value of b is different. For the first term it is 1, for the second term it is 3. So you need to clearly specify, clearly tell the values of R1 phi 1 and R2 phi 2. So that was your second question. Now when we move to the third question, isn't it a very similar question, students? So even if you take the third question, what will happen here? You will this time write cos square as what? Cos square as cos into cos. So you can observe this is cos square x into cos x, which simply becomes what? Cos cube x. So students, you can simply say you are going to get e raised to x into cos cube x, isn't it? Cos square x into cos x can straight away be written as cos cube x. It is given there only for confusion. Don't write cos square x as cos x into cos x into cos x and then try to make use of the formula. It is ultimately going to come cos cube x. Now, don't you recall how to transform this cos cube x? You should be recalling, students, the formula for cos cube x is 3 cos x plus cos 3x upon 4, isn't it? That's the formula. So in place of this cos cube x, you can write this particular term. So you get now e raised to x, a bracket 3 cos x plus cos 3x upon 4. So it is but obvious that the 4 is going to be a constant, so you keep it outside, ultimately outside, and inside the bracket the first term is going to be 3 times of e raised to x into cos x, and the second term is going to be e raised to x into cos 3x. For both the terms you can see that a is same, e raised to ax cos bx plus c. For both the terms e raised to ax is the same term, so a value is 1 for both of the terms, but the value of b is different. For the first term it is 1, for the second term it is 3. So make sure that you make use of the r1 and phi1, r2 and phi2 very properly, and also you need to get those values. So you can observe that all these questions can be easily solved even if I take one single question, isn't it? So I have taken the first question in very detail. This is the solution for the very first question, and I have discussed the rest of the questions. I want you to write the solutions for the rest of the questions. So students, that was all about this particular type. Now we will proceed ahead where e raised to ax is now going to get changed with k raised to x. Rest of the type will remain same. So let's begin with the next type of questions.